Okay, welcome Math 31s. Today we're going to go all the way back to our second unit, which was limits, and we are going to do limits of trig. So remember, when you get 0 over 0, we try a few things. Factoring, rationalize, or just simply simplify. We're going to do a new one, which we use in rationalizing, but it's called multiply by the conjugate. And if you remember what the conjugate is, it's if you had something like x plus 1, you would use x minus 1. So something with a different sign. When we do that, we're creating a difference of squares. So what you need to keep in mind is just keep trying. So we're going to do our trig limit. So the first one we have here is just sine x. So I'm just going to show you graphically. Remember, sine x starts at the origin, and then it has a period of 2 pi, and it looks something like this. When I keep going, the graph looks identical on the other side. But what's important about this one is that from the left and from the right, you are approaching 0. So this limit just equals 0. And that's a standard one we're going to use all the time. For the second one, cosine. Again, graphically, we know that it starts at its y-intercept at 1, comes down, goes to its minimum, and then goes back up. And so this graph looks something like this, and again on the other side it will do the same. Once again, from the left side and the right side, it is approaching a value of 1. So this limit equals 1. When we get into some harder ones, like limit as x approaches 0, when you have something like sine x over x, these ones you just need to know. We use them a lot, so you want to have these ones memorized. And you can look on page 303 for further proof or analysis. But I'm not going to go into it too deep with you because we're not in class time. I don't want to be here, keep you guys on the computer too long watching this. So what this graph looks like, if I were to put it in my calculator, is it has an open circle here because it's undefined at 0, right? So it's not included. And what this graph looks like is it goes this way and it goes this way. And so even though that point is not included, remember, from the left and from the right, it is approaching the value of 1. And so this equals 1. When we have something like number 4, again, sine at 0. Remember, sine at 0 is 0. So we get 0 over 0 for this one, so it's still undefined. What this graph looks like is you have some vertical asymptotes. This graph has a value here. It goes up. And then it has some more stuff down here. And so again, when we look at this graph and we look at it from the left and the right, it has a value of 1. So these ones are ones you want to have memorized because we try to create these cases a lot and we do it quite often. Now, cosine, again, we always want to plug the number in. So when I plug in 1 minus cos at 0 over 0, we get 1 minus 1 over 0, which is 0 over 0. But I can't simplify this function. It's linear. So this is where that new step of a conjugate comes into play. So I'm going to take this limit as x approaches 0 of 1 minus cos of x over x, and I'm going to multiply it by 1 plus cos x, which is the conjugate. What I do to the top, I do to the bottom. Now what that has created is a difference of squares on top. Again, I don't distribute this x, I just leave it as is. And I get 1 minus cos squared. And if you remember that from your trig identities, that is a Pythagorean identity, and that can now be replaced with sine squared x. So that is what I'm going to do. I'm going to write my limit every single time. We can't be lazy. It has to be there. And we get sine squared x over my x 1 plus cos of x. Now, I'm not done because the problem is I still have this x, and that x can't be 0. If I plug it in, I'm going to get something over 0, which is something I don't want. So what I need to do is split this up and get one of those cases that I just talked about that we have to memorize. What I mean is I'm going to write this as sine x over my x, which is out of here, took one of these and used this, times my other sine x over that 1 plus cos x. So all I did is split it up into two terms using my multiplication. I haven't changed anything. Now, because we've memorized this, or will memorize this, this has a value of 1. When I multiply it, and I plug in my value here, sine at 0 over 1 plus cos at 0 is simply 1 times 0 over 2, which still results in 0, but we proved it. Okay, so we didn't just stop. We had to show all of our work. And that's something that's new, is using that conjugate and trying to create these two limits where we get that case of sine x over x or x over sine x. So if you look at number 6, it is the same type of step. So here we're going to simplify by multiplying by cos x plus 1, again the conjugate, over cos x plus 1. If you're going to show that you're multiplying by this, you have to. You have to show that you're doing it both on the top and the bottom, otherwise you'll lose marks. You can't just put a bracket and put cos x plus 1 and multiply the whole thing by it. You have to put cos x plus 1 over cos x plus 1. This limit then becomes cos squared x minus 1 over x times cos x plus 1. Now with this one, again, this is not, this numerator is not just equal to sine squared x, it's actually equal to negative sine squared x. Again, you have to know your identities for this unit to be able to simplify this stuff. And we get our x over our cos x. And we have very similar situation like question number 5, where I'm going to need to split this up into two limits, or into two products, two factors, probably the better term to say. So I'm going to have negative sine x over x times my sine x over that 1, or sorry, cos x plus 1. Here I can now evaluate, because this is a negative, this equals a negative 1, not positive 1. And we're still going to get that same value we got over here, which is 0 over 2. So it's still equal to 0. A lot of work to show that it's equal to 0, but it does have meaning. It gives us a lot of information about the graph and what it's approaching. Number 7. These ones you're going to see quite often. And we're going to try to create, so we want x over sine x, or sine x over x, because we know that they both equal 1. So we're trying to pull that out of this here. So what I want to do for this one is I'm just going to pull out that 1/2. You see that too right here. And then again, I'm writing it as sine x over x. We know this is 1/2 times 1, so the limit equals 1/2. And that's all we need to do for those ones. Okay, and that goes back to our properties on page 3, or page 13 in our textbooks, about properties of limits. Okay, something like this one. Again, you want to know your identities. You want to make sure that you know what a double angle is, because we're going to have to replace it. So I know on my formula sheet, and I can post a 30-1 formula sheet for you guys for this unit if you want it to help you memorize those identities. But sine of 2x is equivalent to 2 sine x cos x. And again, it's just over my x. What do we have here? Well, here we have that sine x over x again. So we have the limit as x approaches 0. We have 2 times sine x over x times cos x. We know this equals 2. We know this equals 1. And when I plug in cos at 0, it's also equal to 1. And so I get 2 times 1 times 1, which is just 2. There's definitely another way to do this, but I'm going to show you using the other two examples, 9 and 10. So this is going to be brand new. There's no identities for this. Okay, so when you have two angles that are random, 7, 5, 3, whatever, we can't replace these with an identity on our formula sheet. So what we're going to do is we're going to create that situation where we had sine x over x, or x over sine x. But when we do this, if I had sine at 2x over 2x, because my angles are the same, it also equals 1. So that's what we're going to try to do here, balancing this equation, or this expression, this limit. So what I'm going to do is I'm going to take this sine x, and I'm going to write this as sine of 7x, and I'm going to multiply it by 7x. But what I do to the bottom, I have to do to the top, remember. So I'm going to put my 7x over here. So I'm multiplying both the denominator and the numerator by 7x. But don't forget, over here, on the denominator, we already had a sine of 4x. So what am I going to multiply this one by? 4x over 4x. I'm balancing out the equation. Because if I were to cancel my 7x's and my 4x's, I get the original equation. So now that I've multiplied the top and the bottom, both by my 7x and my 4x, we can now evaluate. This has a value of 1. These x's cancel. I get 7 over 4. And this last one equals 1. So the value of this limit is 7 over 4. Example number 10, we don't have to balance this one. This is an identity. Remember, always plug the number in. If this was a 0, then we would have to do some further analysis, which we'll do in question 11. But for right now, don't forget about tan at pi over 4. All we have to do is plug the value in, because that is always step number 1. And evaluate. What is tan at pi over 4? It's 1. And this cancel. And what is tan, or what is pi? It's just pi. So the value is 1 over pi, and that's okay. Okay, we have a few more here. Number 11, tan at 4x as x is approaching 0. This is where we get 0 over 0. So for this one, we're going to suck out that 1/4, which is a constant, or pull it out, or whatever term you want to use. And we're left with tan x over x. Remember, this is sine x over cos x, technically divided by x. So what we get is sine x over cos x times 1 over x. Okay, so that's what that one looks like. So I have my 1/4, which I can write in front of my limit. But then I'm evaluating this, and here we have it once again, sine x over x times 1 over cos x. Now we know that this value is 1, so we have our 1/4 times 1 times 1 over 1, because cos at 0 is 1, and what we get is 1/4. Okay, so again, just knowing your identities really does help with these, and I know these can be kind of hard, so definitely take it slow. Here, we have that situation that we can't simplify, so we have to use our conjugate. So we have the limit as x approaches 0 of 1 minus cos of x times 1 plus cos of x. What we do to the top, we do to the bottom. Okay, so you'll start to recognize when to do which technique. Now again, that numerator becomes 1 minus cos squared x, which equals sine squared x. Don't forget your Pythagorean identity. We use it a lot. And you'll see once again, when I get that sine squared x over my 2x, I have that 1/2 there. And I also have 1 over 1 plus cos of x. And we don't mind cos of x in the bottom because cos at 0 is 1. So here I have 1/2, which is right here. Okay, and then I'm going to get oh, I mistyped this one. This one is supposed to be squared. Otherwise, this is a very tricky question. Sorry, this one is squared. And I get 1/2, and then I have sine squared over x squared. And then I have 1 over cos, 1 plus. So here we're going to get our 1/2. This is 1 times 1, right? Because there's 2 of those sine x's over x. And then this is going to be 1/2. So this equals 1/4. Sorry, I missed that one. That 1x squared. I'll have to look at the worksheet to make sure yours is all correct as well. Okay, 13. On your worksheet, the limit as x approaches 0 of 2 tan. Okay, whenever we see these tan and these secants or cosecants or cotangents, we want to replace those just like we did in Math 30. So I'm going to rewrite this as 2 sine x over cos x divided by x over cos x. Okay, because secant is 1 over x, 1 over cos x. Then I'm going to reciprocate and multiply. And I get my 2 sine x over cos x times cos x over x. My cos x's cancel, and boom, there we have it. I'll write it one more time. 2 sine x over x, and you have your sine x over x, which is 1, so we get 2 times 1, which is just equal to 2. Now our last one, number 14, I'm going to do it on another page because I need room. We have the limit as x approaches 0 of tan x minus sine x over x cos x. So right here, when we look at that tan x minus sine x, remember that sine x over cos x minus sine x. So I'll just put it on the side there for you. So what we end up getting here, if I pull that together with a common denominator of cos x, I'm going to get sine x minus sine x cos x all over cos x. Okay, so that's just me simplifying that numerator. So when I put it back here in my limit, I'm going to get sine x minus sine x cos x. Don't forget your x's. You need that angle in there. Over cos x divided by this guy, x over cos, x times cos x. So I reciprocate and multiply. This is 0. I get sine x minus sine x cos x over cos x times 1 over x cos x. You can see probably where we're headed. We're going to factor the limit as x approaches 0. Take out that sine x. You're left with 1 minus cos x over cos x times that 1 over x cos x. Okay, so here I can write this as sine x, 1 minus cos x, all over x cos squared x. And now you can see right here we have that situation and that situation. Evaluate those. That one equals 1. And the second one, 1 minus 1 over 1 times 1. Co-squared is just 1. And so we end up getting 0. You'll get that a lot with these limits, which is okay to get 0 and not a number. And that is the end for trig limits. I know that there's going to be some tricky ones. Just please, if you try it one way, don't stop. Don't just give up. Try it another way. So I will leave that there. Your homework will be on page 306. And I do have some work. I've done all the homework questions, so if you wanted me to scan my work, let me know, and I will put up some homework questions for this unit because I know it's not easy. That's why I wait to do it towards the end of the semester.